Welcome back. In this segment, we'll concentrate on the rationale and anticipated benefits of activities within the eastern area that are included in the proposed Fourth Amended Consent Judgment. If you watched the overview video, you may recall that there are three main activities proposed for the eastern area: mass removal from 2 new extraction wells, delineation along the northern and southern Prohibition Zone boundaries, and a groundwater surface water investigation in the West Park area. Let's examine each of these in turn. This is a map of 1,4-dioxane concentrations above 85 parts per billion in the eastern area. 1,4-dioxane from the original source area on the Gelman property migrated across Wagner Road into the eastern area, forming 2 main plumes. Although that migration has declined in response to pump and treat activities in the western area and along Wagner Road, it still continues today. Dioxane has been removed from the eastern area, mainly by extraction wells in the Maple Village and Evergreen subdivision areas, and also from a horizontal purge well. 1,4-dioxane concentrations observed in monitoring wells within the Prohibition Zone have declined from historical highs of around 10,000 parts per billion to maximum levels today between 1 to 2,000 parts per billion. The areas of highest remaining concentration are called hotspots, and the proposed Rose and Park Lake wells in the proposed CJ revision are intended to remove dioxane from 2 of those hotspots. To see why these 2 wells are important, let's talk about mass removal from a larger perspective for a moment. Over the years, dioxane has been removed by several dozen purge wells located across the Gelman site. Most of these wells start out pumping water with high dioxane concentrations that eventually decrease and level off over time. Today, 7 purge wells are responsible for more than 95% of the dioxane mass removal across the entire Gelman site. 2 are located on the Gelman site in the western area, 2 along Wagner Road, 2 more in Maple Village, and 1 is in the Evergreen area. In the last quarter of 2019, these 7 wells accounted for 96% of groundwater volume pumped and 98% of 1,4-dioxane mass removed from the Gelman system. Together, these 7 wells pumped at a combined total of 450 gallons per minute. Because the average concentrations of 1,4-dioxane in these wells range from 250 to 750 parts per billion, they remove on average about 800 pounds of dioxane each year. This represents the status quo. The Park Lake well is expected to pump at approximately 200 gallons per minute, and the Rose well will borrow capacity from the Maple Village and Evergreen area to pump at 100 gallons per minute. Let's compare the Gelman system with and without these 2 wells. In terms of pumping, the net effect of the 2 wells is to raise the overall pumping rate to approximately 650 gallons per minute, or 32 million gallons per month. The dioxane removal rate would increase to approximately 2,500 pounds per year. Even more dioxane would be removed by the proposed source area extraction wells, but I'm not taking that into account here. Simply stated, these 2 eastern area extraction wells, targeting remaining high concentration hotspots, are expected to more than triple the existing mass removal rate. This is particularly important in the eastern area, where removal of mass from places with the highest concentration is expected to have 2 beneficial effects. First and foremost, decreasing concentrations in the hotspots makes it less likely that exceedances of the groundwater surface water interface criterion will take place as dioxane-laden waters continue to migrate down gradient toward their eventual discharge point in the Allen Creek or the Huron River. The GSI threshold is 280 parts per billion, so it's easy to see why reducing up-gradient concentrations exceeding 1,000 parts per billion would be helpful. I'm arguing that an ounce of mass removal prevention is worth a pound of GSI remediation cure. Second, in addition to flowing along with the groundwater in which it's dissolved, dioxane can also spread by a process called diffusion. This is the natural tendency of any chemical, including dioxane, to move from zones of high concentration to zones of low concentrations, essentially spreading things out. Although diffusion is slower than the rate of groundwater flow, it may be responsible for pushing dioxane toward the boundaries of the prohibition zone at low concentrations. Removing dioxane mass from the highest concentration areas in the center of the plumes reduces the concentration gradient that drives diffusion, and therefore reduces the probability of a PZ boundary zone incursion at 7.2 parts per billion or more at some point in the future. Turning to the proposed sentinel and boundary wells in the eastern area, the position of the northern wells is sensible and necessary to protect against the possibility of northern dioxane migration. These wells fill gaps between 3 existing monitoring wells and extend the line of wells farther to the northeast in a topographically low area that could represent a potential northward migration pathway. Specific actions are required if 1,4-dioxane concentrations greater than 7.2 parts per billion are detected in a sentinel well. In a similar way, specific actions are also required if 1,4-dioxane concentrations reach thresholds of 4.6 or 7.2 parts per billion in boundary wells. The proposed boundary wells along the south may also help to delineate the extent of 7.2 part per billion dioxane, although, in my opinion, the proposed position of boundary well E should be reconsidered and optimized before it is actually drilled. Of greater potential impact is the proposed investigation centered on the West Park area, which is meant to illuminate the potential for groundwater-surface water interface exceedances in the eastern area. In the past 2 years, sampling in the Allen Creek drain system near West Park found detectable levels of 1,4-dioxane at concentrations suggesting that groundwater-containing dioxane could be seeping into the drain system. The new monitoring wells and an accompanying hydrogeologic investigation are intended to better delineate dioxane concentrations in the area and increase everyone's understanding of how the groundwater and surface water interact there. In my opinion, this will be one of the most important points of interest for Friends of the Huron River and its surrounding watershed, because Michigan's current regulations governing protection at the groundwater surface water interface are tilted in favor of polluters by providing them with multiple ways to demonstrate GSI compliance. This is, of course, more of a political or regulatory issue than a technical one, so I will not comment further about it other than to say that I think the proposed West Park activities would be a helpful step in the right direction. Finally, with respect to expanding the groundwater prohibition zone, I'll say this. Evidence from current monitoring wells clearly suggests that 1,4-dioxane concentrations of 7.2 parts per billion or more have approached or even crossed beyond the boundaries of the current prohibition zone. Some degree of expansion is therefore warranted, both north and south of the current PZ, in response to the decrease in regulated levels of dioxane from 85 to 7.2 parts per billion. From my perspective as an outside technical consultant, however, it's difficult to justify the size of the proposed expansion, particularly to the southeast. Of course, this aspect of the proposed CJ revision was, like all of the others, part of the final negotiated proposal. In the next video segment, we'll venture across Wagner Road and delve into proposed activities in the western area.